Okay, what we're going to do today is material related to Math 1103, and in the section 3 of Chapter 2. And you may recall we did mention that we do have this Math Zone additional exercise booklet, chapters 1 through 5, the exercises that pertain to Math 1103. And what I'm going to do is work on some of these exercises that are in section 2.3. And they're listed out here. I'm not going to do them all, but to give you an idea of how to do them. So, as we see in this first exercise, we have a formula. And what they want us to do is to solve for the letter W. And in the previous video, I did go over the steps for solving an equation. Get rid of fractions, grouping symbols, combine like terms, transpose, and isolate the variable. So basically, this is what we're going to do here. And let's look at Formula 1 then. This is the formula for area, in which we want to solve for the letter W. So in a sense, the L is the coefficient of W, the term that is with the W. So we're going to get rid of it by dividing both sides by the letter L. Remember, we need to keep our balance. So when we do that, here the L's cancel out, and we get then W equals A divided by L. So this is probably the easiest of the examples. Well, this one is very similar. So we want to solve for D, and by the way, this is the circumference formula, the area around a circle, or I should say the distance around the circle, the perimeter of a circle, and pi d. D is the diameter of the circle. So if you multiply the diameter of the circle by pi, you get its circumference, distance around, perimeter. So we want to solve for the letter D, so we're just going to divide both sides by pi. Here the pi's cancel out, and this is equal to D equals C over pi. Now, one thing I noticed as I was watching students work is that sometimes they would confuse a capital letter D with the lowercase letter d. You can't do that when you're solving for these formula. All right, this next one's, again, a little more sophisticated. Here we have two terms. And again, it's an equation because of the equal sign. We want to find what S is. So here's a term that we want to put on the other side. So we can isolate this. So this is actually step 4 over there, where we're going to transpose this. Now, we had used the word before, but we didn't really describe it. And what we are going to do is take this term, and remember there's sort of a positive sign in front, and bring this term over to the other side. That's what transpose means. But when we cross the equal sign, the sign of what we are transposing changes. So on this side it's positive, so on this side it becomes negative. So we are taking this term and in a sense adding its additive inverse, which is a negative this, So on this side it becomes 0, and on this side it becomes the negative pi r squared. So transposing is the same as adding the additive inverse, except it's just a little easier. Take a term from one side, bring it to the other, just change its sign. So now we're left with pi r s. And remember, it's the s we want to solve for. So as we did up here, when we have something times something times something, we get rid of, in a sense, a factor by dividing those factors out. And then over here, so these now cancel out, and we're left now with s equals a minus pi r squared all over pi r. Now, you could also do something here. Watch what happens if I separate this into two parts. And I went a little went a little further than I should on the line here. So this would be like two terms. I would accept it as this, and most authors would. But here we could cancel out the pi, and we could cancel out one of those. So we're left with a final answer then of s equals a over pi r, and then that would be minus r. Both of these answers are equivalent, but this one is a little more simplified. Now again, I'm using these additional exercises for section 2.3. And I already have a integrity program for this, but here's a little YouTube video. So in this case, we want to solve for the letter N. And in this case, later we'll solve for the letter C. And we want to continue using the techniques of solving an equation. So here we want to isolate the letter N. So we want to get this 10 on the other side and think of it, which of those items are we going to use? And it's number 4. We're going to transpose the 10 to the other side. When we do, that becomes C minus 10 equals 3.5n. So we're taking this term from this side, transposing it by adding its additive inverse, which is a negative 10, to both sides. This side becomes a 0. Here we have the negative 10. So it's just a shortcut. And then now to isolate in number 5 the variable that we're looking for, we'll divide by its numerical coefficient. These cancel out, and that's what our answer is. This one you'll run into later in the course as you do some things, and they want you to solve this equation for the letter C. And that's step 1, get rid of all the fractions. So these are fractions. Now how do you get rid of all the fractions? Well, you multiply by the lowest common denominator, which happens to be, in this case, A, B, and C. So I'm going to multiply every term by A, B, and C. So as I cancel out the A, I cancel out the B, and I cancel out the C. Now I rewrite my equation, and I get BC plus AC equals AB. And once again, I want to solve for the letter C. So let me highlight it here. And notice C is in two terms. They're both on the same side, which helps. And we want to isolate the C. Well, how do we get the C out of two terms? Well, we had this in Chapter 1. It was called the Distributive Principle. And if we reverse the Distributive Principle and take a C out of each term, here I take a C out of this, I end up with a B. I have to put it in parentheses. And then this will be B plus A here. So before we had this type of thing in Chapter 1, C times B is CB or BC, and C times A is AC or CA. But now we want to take the C out of two terms. And we do that through a process that's called factoring. So through factoring, we are taking out the letter C from each term. We had gone this way using the distributive principle. Now the opposite or the reverse of it is called factoring. So here we're going to factor out the letter C. And then this now equals AB. Now that we have the C by itself, we're going to divide by this, which is B plus A. And keep in mind, you could reverse these, the commutative principle, and have it A plus B. So we can do it that way. And that cancels out, and that's our answer. So C equals AB over A plus B. Now, let's just modify this a little bit while we're here. In fact, I'll set it up.